I was told by my colleague, Dan Blumstein, who I think spoke here last year, that this was a conference that I had to attend, that the conversations were very much in line with what we're talking about, and he said, do not miss it. So I'm already very glad to be here. We have lots to talk about, so here I go. So 50 years ago, a little over 50 years ago, right, the Nobel Prize in Medicine and Physiology is awarded to 3 animal behaviorists. And it was awarded to them based on the belief, maybe the hope, the promise that animal behavior could transform our understanding of human psychopathology. Now, in the past half century, I don't think that has really happened, but in light of emerging technology in terms of tracking animal emotion and animal behavior and linking it to animal affect on scale, and this process of integrating and breaking down long-standing human exceptionalistic boundaries, I think we may find that animal behavior now is poised to transform our understanding of human mental health and well-being, and maybe human and animal mental health and well-being. All right, so I say that, but I want to make there's a caveat, which is that will happen only if we can move beyond long-standing traditions of human exceptionalism and anthropocentrism in the field of medicine in general, but especially in the field of human mental health. I'm going to circle back to that. Let me give you some context. So I began my career as a professor of medicine, a cardiologist at UCLA, at Los Angeles, where I had a specialty in heart failure and cardiac imaging. Around 2000 or so, 2003, 4, 5, something like that, the Los Angeles Zoo and then other zoos began inviting me to come and provide some cardiovascular consultation on some of the great apes, and then expanded phylogenetically to some other animals. And it really was an eye-opening experience for me, basically because I realized that vulnerability to diseases that I had just assumed to be uniquely human, that vulnerability existed across a very wide range of species. And that was not just somatic diseases, but of course, psychopathology as well. This is not a surprise to any of you, but I have to say it was a surprise to me. And it certainly is not something that is a part of any kind of mainstream medical education that I know of, certainly not in the United States. And as I learned more and more about the overlapping vulnerabilities, it became clearer and clearer to me just how much of a blindfold this anthropocentric framework in the field of human medicine really was. I mean, yes, we talk about comparative medicine, but we're really talking about a handful of model organisms, right? But otherwise, we're really looking at humans in an uncoupled way, right? The field of medicine is one of the worst perpetrators of, the falsest of false dichotomies, humans and animals. You just hear it all the time. And I began wondering, really realizing how narrowing this was, and couldn't help but I came to believe that if we could expand the window through which we perceive health and disease to include the other, depending on what number you want to use, let's be generous, 30 million metazoan species with whom we currently share the Earth, extant species, and then widen that window one more time to include the evolutionary history that shapes the similarities and differences in health vulnerabilities between species. If we could do that, we could transform our understanding of diseases, of the causes of diseases, and be more nimble and creative in developing novel therapies. And this is true for physical illnesses, of course, but also for mental illness. And that's going to be the focus of today's conversation. And this has been my focus for the last several years. I've been working on a book for now probably 5 years. This is and it focuses on the animal origin of human affective disorders, but I believe this is a real possibility. To illustrate my claim, and I'm going to cast it as a claim that if we can be far more comparative, I mean, really embrace a comparative approach in a truly phylogenetically wide kind of way, and if we can apply evolutionary lenses, right, to human medical challenges, that we can accelerate innovation and understand causation. So that's the claim, and I'm going to use depression as the kind of example to see whether I can make good on the claim. Interestingly, the National Institutes of Mental Health, their mission is to transform our understanding and treatment of mental illness. So I feel like, okay, this is something that is certainly an endorsed path. Let's talk about, I think I'm going to just use the computer directly. Okay, so why depression? Depression is a huge issue, as I think we all know. At least 250 million human beings suffer from it. Globally, it is increasing in incidence. And of course, suicide, which major depressive disorder is the leading psychiatric disorder underlying suicide, and suicide rates are on the rise, particularly in certain vulnerable age populations. Depression is a very major concern. And I want to start to make good on my claim by breaking depression down into two of the elements that are associated with it. The first are these neurovegetative symptoms, these physiologic symptoms of depression that include energy loss, physical exhaustion. Sometimes they're referred to as psychomotor slowing in the DSM-5, which is the diagnostic Bible of psychiatry. Psychomotor retardation is sort of one of the core elements. So that's one component of depression. And the other that I want to focus on is this issue of profound pessimism, a certainty that it won't get better, or hopelessness. And I'm going to just put those out there as we start, and I'm going to begin to talk about each of them and then circle back. So previously, I sort of asked the question, why this matters, and I was showing depression and its importance. I think I skipped past that slide. But I want to take a moment to share why it matters to me. And this is not a part of the talk that I have done before, but I thought today would be the perfect day to do this. I've always intended to do this, but I was, for reasons you'll understand, reluctant to do so. Let me go a little bit earlier before I was a professor of medicine. So I was born in Los Angeles, California, to two psychoanalysts. And my father at that time is a physician, so he's an MD psychoanalyst. In those days, women were not really going to medical school very much, but my mother was a psychotherapist, PhD, and I consider her a psychoanalyst because she was psychoanalytically oriented. Anyway, that was the framework of the household that I grew up in. I went to Harvard as an undergraduate and really stumbled truly into my freshman year bio course with E.O. Wilson. I mean, he was my freshman year biology teacher, which is kind of incredible. I did not know who he was when I was taking the class, but I really fell in love with biology and particularly animal behavior. I worked in Carl Leem's fish lab. And by the time I was finishing, I stayed for an extra year to get a master's. I had the opportunity to have Stephen Jay Gould as one of my thesis advisors. So this was like, when I look back, I just cannot believe I was a bumbling, I didn't really understand how I was being exposed and shaped, and until actually decades later. In any event, I went to medical school, and I loved cardiology, I loved surgery, I loved everything, but I also liked psychiatry, and it was sort of the family business. So I decided I would become a psychiatrist and come back home to LA, which is what I did. And I should say that my parents were very prominent. In Los Angeles is kind of it's like a Hollywood town, and they were very well known professors, therapists to the stars. We were taught at a very young age to be very discreet, and so there's a lot of pride in our family about this. And then here I was coming back, and I was at UCLA and everything. In any event, I was a first-year psychiatry resident, so I'd finished in 1 year of internal medicine. I was in my first year of psychiatry, and I admitted a woman, young in her early 20s, who had bipolar disorder, and she was in a depressive phase, and she had made a suicide attempt, so she was admitted, and she was admitted to a unit at the hospital, which was locked. She was doing well. Remember, this is 87, 88. So Prozac, the first of these selective serotonin reuptake inhibitors, did hit the market, the US market, until 87, 88. So we're really talking about a period when the medications that were used for depression were much harder to take. And so most of the treatment was psychotherapy, actually. In any event, she seemed to be getting better, and we went on rounds, and she said she was feeling much better. And so the decision was made to give her a little bit more privilege. You know, when people start to get better, then they're allowed to go with the group and into the little town there and, you know, buy candy or whatever at the drugstore. To make a long story short, I happened to be on call that night, and we got, and it turned out she had overdosed, and she had overdosed with something that she had taken. She had purchased. And this was traumatic on so many levels. I don't think even at the time, I think I was in denial, but the grief and the guilt and the shame and the all of that was huge. But more than anything else, it was the ruminating around why this happened, why this happened, why this happened. And even though I finished my residency in psychiatry and I was chief resident, I privately knew I wasn't going to stay in the field, and I didn't. I retrained. But when I look back now, I realize I did not feel comfortable being in a field where I didn't understand why this had happened. I really didn't. I talked to everyone. I could not understand in a really kind of scientific way. I mean, I could, in a reductionistic way, give little answers, but I didn't have a holistic kind of understanding why. So I think I really changed fields because I didn't feel comfortable being in a field where we couldn't explain why. And I actually went into a field where there's much more death. I mean, it's cardiovascular medicine. But there's a more of a kind of an explanation. So with that, I will say that I then, was professor of medicine, cardiology, doing a lot of just traditional kinds of clinical research, a lot of teaching. The zoo thing was sort of serendipitous. I happened to be directing our imaging lab, and they needed somebody who could do what I didn't, so I went. But when I got there, it reactivated, I think, my interest in animals and evolution, and it just kind of stuck. And so I began doing more and more zoo consulting, still working full-time as a physician at UCLA as a professor of medicine. And more I wanted to figure out how could I take what I was learning comparatively, because at this point I was going to veterinary conferences. I was becoming very, very interested in this. But how could I use this experience to ask questions that a professor of medicine is supposed to be asking, so that I could use this comparative knowledge, this experience to improve human health? And so I'm just going to kind of quickly, so I'm putting 15 years into 2 slides, but I've created courses and written books and papers and programs to really push against this human exceptionalism, which I see as a scientific blindfold. There's a real opportunity in the field. I'm not sure how successful I have been, but I'm trying. But what really helped me ultimately was when it was probably Dan Blumstein who reminded me about on the aims and methods of ethology. And people here have certainly, if you haven't read it, you're very familiar with, this is probably one of the few groups where I don't even need to say very much about Nico Tinbergen. But of course, Nico Tinbergen was one of the 3 laureates who won the Nobel Prize. And of course, what he did in this paper was he called out really to the biology community the deficits of looking exclusively in a reductionistic or developmental way, and the necessity of considering an adaptive perspective. And to do that, it requires really a broadly a phylogenetic view. And so over a couple of years, I developed methods to a kind of a hybrid method that was based on this way of thinking, and brought in a method from medicine to study a range of diseases. But the more I used Tinbergen and the more I read about him, you get into a scientist, and then there's a biography, and you read the biography, and you know how that goes. And I was really lucky because there is an incredible biography written by one of his former graduate students, Hans Krug. And I hope somebody here knows Hans Krug, because I've tried to reach out to him. I haven't heard back. But if that's possible, I just want to tell him it's an incredible book. I've given this book to all of my grad students and TAs over the years, so I don't know how many copies I have given. But in the book, Hans Krug has a small section about Tinbergen's depression. And what's remarkable about this on many levels, but was the openness that Tinbergen had about talking about his depression. Remember, depression still is very stigmatized. And I think in line with who he was as a human being, he writes about it, and there are quotes from letters and in this book that really describe it. So this is where I first learned about Nico's depression. I'm going to call him Nico because he's such an important part of my life. I've connected with his family and others, but and what I really wanted to do, I thought, I wonder if Nico Tinbergen wondered about if Nico Tinbergen could do a Tinbergen analysis of his own depression, what would that have looked like? I mean, it kind of became a framework. I did my first year as a visiting professor at Harvard in 2016, something like that, and I had a seminar where we actually did just this. But actually, what is the question? That the unknown is really, what is the adaptive value of depressive behavior, right? And this is a question that's been around for a really long time. But it's been a question that psychoanalysts and psychotherapists, people who are very much focused on mental health from this human-only perspective. And so they can have theories about the adaptive value, but since they are not really aware very often of the ancient origin of depressive-like behavior, they cannot really they don't have a way of identifying the selective pressures, the actual selective pressures that might have shaped the emergence of neurobiology that produces depressive-like symptoms. So this became sort of something that I thought, well, maybe I can do. It became I don't want to call it an obsession, because it's been wonderful and uplifting to spend a lot of time. I went to the Bodleian. My husband and I went for a week, and where his letters, Nick Tinbergen's letters from his early part of his life, are there. If you're there, many scholars have looked at them. It's really pretty thrilling. And in any event, I don't want to use all my time talking about all of that, but I'm happy to have lunch with people and talk about it. I went last year. Ricardo Lorenz invited me to Altenburg, which is, of course, where Nico and Lorenz in 37 were 37. Yeah, it was 37 or 38. They spent those months together, and that's really kind of founded the field of ethology, more or less. And then when I got to Harvard, the wonderful thing was Pusey Library, which is one of the libraries where they have historic papers. Nico and Ernst Mayr, who was an evolutionary biologist, and he was a curator at Harvard's Museum of Comparative Zoology, they wrote back and forth constantly, and so those were available, and many of those were in English. And I also happened to have a German undergraduate who translated stuff, so it was wonderful. I even brought my parents into this. This is my mother on the left, my father, and he's holding a pencil to be one of the cigarettes. They both read Nico's Nature, and very carefully, and Nico was a chain smoker, and so they have this dialogue. Nico was treated briefly for his depression by none other than John Bowlby, who was the father of attachment theory. I mean, there's just so many really wonderful connections. In any event, I want to get back to that. That is all setting the stage for what I want to share about how I believe a Tinbergian lens, a broadly comparative, phylogenetically informed lens, can begin to reveal to us the adaptive origins of depressive-like behavior, which in turn, I think, can lead to potentially to applications in human medicine that I believe are being overlooked. All right, so let me say that. Let's go back to the neurovegetative symptoms of depression, this exhaustion, this psychomotoric slowing. The DSM-5, the Diagnostic and Statistical Manual for Psychiatry, identifies You've got the major symptoms of the depression. In red, we have these decreased appetite, sleep disturbance, psychomotor retardation, fatigue or loss of energy, cognitive slowing as well. Very, very characteristic. And I want to begin to show you this kind of model. For years, well, people have been trying to develop animal models for depression. Lots of this has been drug companies trying to develop animal models to test new drugs on. And one of the protocols that has been used is the social defeat protocol. I think people here understand what social defeat means. It's social defeat in animals refers to the consistent and repeated subjugation of an individual by a dominant counterpart. Again, this is a very informed crowd. If we can go, it goes back to the pecking order, our Norwegian, whose name I never like to pronounce, who actually observed that alpha birds who were deposed from their high status experienced severe life-threatening depression. So that's really rapid status descent. And there have been experiments identifying very similar responses to social defeat, including yielding behavior, subordination behavior, appeasement behavior across a pretty wide range of not just vertebrates, but even invertebrates. Pretty interesting. So in any event, social defeat protocols have been developed. This is from 2019 from Hiroshi Okamoto's lab at the Riken Institute in Japan. And you can see the contests were sped up, and the basic protocol with the fish is that a fish who's like 20% smaller, one's 20% bigger, one's 20% smaller, you're going to set the situation up where you're going to create an animal that has this motor motor slowing. Oops. Let me go back to where it was. I want you to take a look. Okay. Oops. So, okay, here we go. We'll just give it a second. The fish, who's the loser fish, is there's psychomotor retardation, there is metabolic changes, there are a number of physiologic features that are aligned with what we see in human neurovegetative depression. And actually, the transcriptional signature of neurovegetative depression in humans is very much aligned with what these animal models show us. So, since 2019, there have been a number of people, a number of groups that have used different species of fish, mostly zebrafish, but in some cases, those who are being funded by, for example, aquaculture, like Marco Vindas. Does anybody know Marcos here? He's a wonderful person. He should be at this conference. So I have been, on this, tracking this story for a really long time, and I saw, I guess it was almost 2 years ago, I came across this paper. And Marco has been using social defeat protocol to induce depression in a number of fish that are important to aquaculture, including rainbow trout. He's at the Norwegian Life Sciences University. And I read this headline, this title rather, and I thought, oh my gosh, he has proven the social defeat hypothesis, I think. And the reason I say that, right, is that even though all of these psychiatrists have been, Randy Nesse and others have been talking about the adaptive benefit of depressive behavior, how do you prove an adaptive hypothesis? You can't really prove it in human beings, right? It's pretty unethical and be pretty hard to do on scale. But so what he effectively did was to create, and these are, I was in Norway several months ago for a follow-up experiment. The videos I'm going to show you are from that experiment, but I'll tell you what he did. So he created, so his protocol starts similarly, 20% smaller, a size gradient, which then after several days of forced togetherness, you see that already there's withdrawal. There is some, you can see by the rate of the gills, there's some motor slowing. And then by day 7, this was a very susceptible individual, the subordinate. Interestingly, these are all siblings, so there are 600 to 800 eggs in a rainbow trout clutch. And some of these, talk about individuality, some of some will not become DLS. Some do not become depressed. Others do. Occasionally, a smaller fish will become dominant. So there is a lot of variation just within that group. But You can see what happens, and not only is there slowing, there's color change, probably activation of melanocortin, which we see in human depression as well. And now this is full-on neurovegetative, I'm going to call it state, where the fish isn't eating at all, and you can see very, very, very slowed. Now, when I saw that, it was kind of breathtaking to me because it's so startling, but it's not more startling than when I was a medical student and I saw a human being with neurovegetative depression. And as I mentioned, we're talking about transcriptomics that are highly aligned in the fish and at least in zebrafish, we know that, with humans. So very, very similar. And two things struck me. One, the similarity, but two, you see this and you realize this has got to be temporary behavior, right? It would not be, it's like hibernation. This is a temporary holding pattern, which means the neurobiology that evolved to produce this behavior, there must also be neurobiology accompanying it that produces an exit from this behavior, a recovery. But in any event, the hypothesis that Nico had was that this depressive-like state represented a kind of a haven from the dominant, and he proved it by giving subordinates ketamine. And ketamine resulted in a rapid reversal of the depressive symptoms within hours. He said it started to really change. And when that happened, the dominant, realizing this had happened, began to attack and attack and attack. And Marco had to take the subordinates out of the tank to avoid their death. And that suggests that depressive-like behavior was providing adaptive benefit from this conspecific violence. And so that felt pretty much like, well, I'm not saying it's the only explanation, but that's pretty impressive. And so if you look at the fish, this neurovegetative fish, for a second, ask yourself a question. Okay, first, are these the same? Well, phenotypically they're same. We use 3 criteria for an animal model, right? To see whether an animal model is relevant to human biology. We look at the face validity, which is sort of the phenotype, the behavior, very similar. We're going to look at the construct validity, which is going to be the neurobiology. And then we're going to see whether the predictive ability, whether when you give drugs, whether you see a similar effect. And all 3 are met in this animal model. So this low energy and exhaustion that we see in humans, is this our subjective articulation of the shared phenomenon of DLS that we're seeing in the fish, that we retain the neurobiology and is produced in us? And interestingly, patients often report as the primary symptom with major depression, not sadness, although that's common, but no energy, exhausted, can't do anything, which, by the way, adds to the self-stigma and a lot of the shame, and a lot of which of course just compounds the suffering. So if you think about Nico Tinbergen, and you know Nico Tinbergen worked with many species. He's best known for working with gulls, but he worked with a lot of animals, and of course the stickleback fish. So I like to kind of imagine Nico with his binoculars looking at fish. But here, this is from Hans Krug's book, is his description in a letter to his dear friend Konrad Lorenz of his depression. This is so, I don't think there is a better description of neurovegetative state. One simply cannot snap out of sitting in a totally fetal position, eyes closed, face turned away, screwed up my whole face with eyes closed, hunched shoulders, inability to speak, apart from soft mumblings. I could pull myself together, but for minutes only, and even that was exhausting. Unable to take in or think, very depressed and totally inefficient. So that is neurovegetative depression, and I am putting it out there because I believe, after my trip to Norway, that there is a connection here that could have profound meaning, not just for the science of it. I'm not a molecular biologist by training, but even in terms of our understanding of the nature of depression, which continues to suffer from all kinds of negative, wrong explanations. And this is from his wife. Lise wrote about him. What I find striking is that more and more, I get the unreasoned feeling that his trouble is more physical than mental. And of course, neurovegetative there is no physical or mental. We know that, right? But the neurovegetative symptoms of depression are the physical symptoms. One of the reasons for thinking this is color is gray, his utter fatigue, and anything except his own misery combined with a total loss of appetite. And by the way, the loss of appetite and the low metabolism in the fish helps, of course, the adaptive hypothesis, prevents the fish from presumably going after food, which could precipitate attack. So again, one wonders, are we looking at, in humans who are neurovegetatively depressed, are we looking at this legacy physiology? Now, when you look at this trout, when I look at it, though, I wonder what is keeping the trout withdrawn? Okay, so maybe what keeps the trout in the corner? And to answer that question, I think we can go back to the first, neurovegetative symptoms. And so the physiologic slowing could be part of it, or a major part of it. One other big clue is when human beings develop major depressive disorder, they have high levels of inflammation. You probably have heard about this before, but usually we say, oh, people have depression, and then they develop inflammation as a consequence of depression. Like the depression is here, and then there's this inflammation, and that inflammation underlies a higher rate of heart attacks and strokes and a whole bunch of other medical morbidity associated with major depression. But what if inflammation isn't a bug, it's a feature? What if systemic inflammation leading to myositis, inflammation of the muscles, which is what you see, all of that, maybe that's part of the mechanism through which you keep the trout in the corner. Right? So this is sort of the thinking out of the box that we can, that just trying to be more like Nico helps us think that way. The second part of depression is hopelessness. And that is one of the reasons that there is, hopelessness is tied to suicide risk. It's this certainty that patients become profoundly sure that they will not get better. Nico writes, one is firmly convinced it won't pass. In these morbid depressions, it is the subjective feelings of despair that disappear last of all. Good John Bowlby, so his good friend, and Anthony Storr, another biologist, came to cheer me up to say it always passes, but of course one is firmly convinced it won't pass. It is the best description of hopelessness. I mean, so what is that about? Well, if we go back to the zebrafish, and Marco has not done this on the rainbow trout at this point, but you all know about cognitive judgment bias tests, which are used more and more in animal welfare to determine animal affect, right? It's where you train an animal to receive a reward with one object and exploring one object, and then no reward with the other, and then an ambiguous object is placed. And how the animal responds to the ambiguous object reflects their internal affective state. And I'm not saying affect recklessly. It has become mainstream within animal welfare to use cognitive bias, the cognitive judgment bias tests to determine affect in animals. So what do we see in a zebrafish who's become profoundly DLS from social defeat? Extreme pessimism. A shift from optimism to pessimism. So in this hypothesis, and it is a hypothesis, is that how you keep the rainbow trout in the corner is through this biological mechanism and also through this motivational mechanism that is being studied for other reasons. Okay. At a time when the field of animal behavior is being transformed by technology. It just is. My guess is people in this room I want to learn, I'm here to learn. The AI facilitated, the non-invasive emotional state detection using facial expressions as a universal indicator of stress. I mean, this is happening in dogs. It's, there was a study, this AI-driven machine learning analyses of vocalizations to reveal emotional states in ungulates, pretty high accuracy. So we are beginning to see that there is going to be the ability to actually measure and determine animal affect at scale. And that means that we may be able to look broadly across species for patterns that can reveal all kinds of insights, that the best reductive biomedical investigation into depression has not been able to find. I think we are poised to see that. Animal behavior I think we're about to see a transformation. But for that to happen, we need to shift the foundational assumption from dissimilarity to similarity. So as I mentioned before, in medicine, in the field of medicine, there is this, that human exceptionalism takes the form of just unexamined, multitudes of unexamined assumptions about human uniqueness. And the biology tells us exactly the opposite. And so we need to invert the null hypothesis. We need to shift our foundational assumption to commonality. And that mindset, I think, will help remove some of the resistance and the scientific headwind that is blocking the field of human mental health and the field of animal behavior coming together. Marco is so magnificent. He is he's a brilliant thinker, a great investigator. We've had a lot of conversations. And I gently said, Marco, you never use depression in your papers. It's always DLS. And not just him. He goes, yeah, well, I can't say that the rainbow trout are depressed. And I would say, given what we know, why not? And is it time to ask whether we're contributing to the problem by tiptoeing around a reality that may interfere with certain human exceptionalistic views, but there are some longstanding traditions that need to be changed. And so I want to end by just reading to you what Björn Fronholm, so he was the psychiatrist from Karolinska who actually gave the Nobel laureates the Nobel Prize, and this is what he said. He said, the discoveries made by this year's Nobel Prize laureates were based on studies of insects, fishes, and birds, and might thus seem to be only of minor importance for human physiology or medicine. But, I'm going to add that, their work will help us to understand the human mind, human behavior, and, as he calls it, human disbehavior. Again, it has not happened in the past 50 years, but I believe we are scientifically at a place that it can actually happen now, but that depends on us moving past these longstanding traditions of human exceptionalism, which are scientific blindfolds. And I'm just going to end by saying I feel like I've been, that Nico Tinbergen has been kind of a guide in a way. Scientifically, I mean, he really helped me shape my research program in evolutionary medicine, but this additional element has just of his life, and it just feels like he's been a beacon. So I just want to end by gratitude to Nico Tinbergen, and thank you for your attention.